Welcome to solverfy.
Hi everyone, so what we have is a motorcycle going up a hill. At A, we know the initial velocity is 1 meter per second, and at this point, the velocity is increased by 0.1 meters per second squared. We know that the hill the motorcycle is going up has a profile such that y is equal to 0.5x squared. What we're asked to solve for is the velocity at 5 seconds and acceleration at 5 seconds. So what we're going to do first is go ahead and break these components up into normal and tangential accelerations. So we know that at point A, when this acceleration is applied, this is a tangential acceleration. So what we can do is we can say that AT is equal to V dot, which is equal to 0.1. And we know that S is equal to S0 plus V0t plus 1/2 a squared. By plugging in for the values that we know, we can say that this is equal to 0 plus 1 times 5 plus 1/2 0.15 squared. And this gives us a total S equal to 6.25 meters. Next, what we can do is we can go ahead and integrate, because what we can say is that the integral from 0 to 6.25 of ds is equal to the integral from 0 to x of 1 plus dy over dx squared dx. Now this just comes from the Pythagorean theorem, because we're saying that this dl is made up of dx and dy, and this is just the dl is just the hypotenuse of our triangle that has legs dx and dy. So what we can do is use the profile that's given to us and say that since y is equal to 0.5x squared, we know that dy dx is equal to x. Therefore, we also know that the second derivative of y is also equal to 1. So what we can do is we can plug these known values in to our expression here. Also, this squared should be outside. And what we end up with is that 6.25 is equal to the integral from 0 to x of the square root plus 1 plus x squared dx. Now computing this integral on the right side gives us that 6.25 is equal to 1/2 x is equal to 1/2 times x, 1 plus x squared plus ln x plus the square root of 1 plus x squared, all evaluated from 0 to x. And what this does is it gives us an x that is equal to 3.184 meters. Now what we can do is invoke our definition of instantaneous radius of curvature and say that rho is equal to 1 plus dy dx squared, all raised to the 3/2 power, all divided by the magnitude of the second derivative, dy squared over dx squared. Now this simplifies down to 1 plus x squared, all raised to the 3/2, all over 1. Evaluate this at x is equal to 3.184, gives us a rho that is equal to 37.17 meters. Now what we can do is again say that v is equal to v0 plus at, and we can say that this is equal to 1 plus 0.1 times 5, which is equal to 1.5 meters per second. Next, we can say that our centripetal acceleration is an, which is equal to v squared over rho, and say that this is equal to 0.0605 meters per second squared. Using this piece of information, we can go ahead and calculate our total acceleration, which is going to be made up by this normal and our tangential acceleration that's given to us. So we'll see that a total will simply be the square root of at squared plus an squared. Remember that at is given to us as 0.1 meters per second squared. So this gives us a total acceleration equal to 0.117 meters per second squared. So this is one part of our answer, and also our answer is our velocity at 5 seconds.